for this year. Okay, so to kick things off, right, what we are hoping to do through this panel discussion is to help most of you to understand the different rules that are out there with regards to data, okay, and also what kind of skills and knowledge that you should be getting or try to get in order to score an interview and even score a position in that particular role. So that will be the main focus of what the panel discussion will be. So feel free to ask questions that's related to those pointers that I mentioned. So without much further ado, let me introduce the panelists first. So our first panelist is Eugene, who's a data scientist from ucare.ai. So his role is data scientist, right? Yeah. So I must make sure everyone knows that data scientist role. Okay, next we have Jadid. Jadid is from NTUC. So he's actually currently a machine learning engineer in NTUC. Next, so a round of applause for Jadid, please. Can Eugene, please? Okay, next we have Michael from Agilent. So Michael is actually a business intelligence and data analyst from Agilent. So a round of applause for him, please. And last but not least, we have Weina. Weina from Rakuten, who's a research scientist over there. So actually, we really do look forward to having more ladies in the panel. But for now, we can only find one, unfortunately. Kaixin, you work on it, okay? Yes. Okay, so without much further ado, let's start the panel first. Okay, so I'll take a seat. So a round of applause for me, please. Yeah. Okay.
And what about yourself? Who are you, Ku? You want to introduce?
Oh, cool. I'm the moderator for today. Yes. Oh, sorry. I'm actually a data science and analytics instructor over here. I'm also the co-founder for Data Science SG together with Kaixin right over there. So today we sort of scissors, paper, stone. So I become the moderator and he operates the Slido over there. Yeah. So in any case itself, let's start the ball rolling. So I think for the first question, same thing. So what we will ask for the panelists is, can you describe your role? What's your day-to-day? What does it entails? And so on and so forth. So I think for the start, maybe that Eugene? Yeah.
Okay, I think this is a common question that you get when other people are interviewing for your company. I usually say that I like to try to spend 50% of my time writing code, looking at the data. 20% of the time I do research, like read up-to-date papers, try to apply it. 20% of the time I do what we call leadership activities like budgeting, resource planning, hiring. And 10% of the time I do external communication. Like this counts as one, communicating with other clients counts as one, talking with potential investors or trying to get incentives counts as one as well. So that's why I do half technical, half non-technical.
Okay. Ready?
So my role is mostly technical. I work day-to-day with data scientists. Most of the work is about taking the models that they have built and making them run in production. The previous role, when I was a data engineer, it was almost always development. So half of the day either it goes in development, and the rest half of the day is usually debugging. Right? So just monitoring your workflows. If something has failed, then do cause analysis, try to find the right fail, try to find the bug fix. So very closely related to be a backend engineer or a software engineer.
Right.
Michael. Yeah.
Can you listen?
Okay.
So my daily job is mainly business intelligence. So what we do is looking at dashboards, making sure it runs, designing those dashboards, and making sure that people who get it get actionable insights. You don't want like thousands of charts and no one gets anything out of it. So a lot of it is making sure those charts actually mean something to someone and it's valuable to read it. On the other half, when things go right, what we are also looking at is solving business problems. Sometimes they have questions about, hey, I have this objective, I want to get this, what's happening here? we basically crack open the data set. We have to look at what are the trends out there and analyze and basically give our recommendations through there. So usually a lot of delivery through PowerPoints. You might have to give some presentations to senior management once in a while. On the other hand, we also look at how we are also trying to improve our internal processes so that we get better data quality, and we also try to educate a little bit of the users who are using our dashboards, making sure that they know how to use our stuff and they know how to read those charts properly.
Okay, so I'm a data scientist. I work in RIT Singapore. So my daily work is so the working time is from 9 to 6. So a bit flexible, but my working is just to write some code for data manipulation. Then I debug. Then I haven't heard those guys talk about machine learning models, and I feed the data to the machine learning models, and I debug. I evaluate my results during all those processes that I have to debug. So it sounds like I'm a software engineer. Maybe it's also a good chance for me to take a step back to explain what is a data scientist, machine learning scientist working process. First of all, you have to get a kickstart of your project. So it's either the, I think some business, they have the problem, they have some issue, they want your help. So they will come to ask you. Or you have some awesome idea that you can bring some profits or make some great impact to those business. Then that's a kickstart of the projects you can start. Then step one is you get the data from the data engineer team. Those data are relatively clean. They have clean for you. That you just get access, get the permission to use their data. Then the second step is to try to clean the data again to fit your format, check your machine learning model, then fit that format. Then the step 3 is to train your machine learning models and evaluate the results. If you feel confident enough, then you go to step 4. Then you have to make some good enough, at least a good enough visualization to talk with those stakeholders from the different, from all the relevant businesses. So if maybe they need to take some corresponding direction, then you have to push them to take the action. Then step 2 to 4 is a loop. You have to do it a few times until you can really go to the final step to deploy your model. So that's a day-to-day job. Maybe the project may take like a few months, but you just have to follow this process. Thank you.
Thanks, thanks, Mina. Okay, I saw the first question up there, right, is what do you feel is the most valuable skill for your role? But let me add a small twist to that. So in your day-to-day, right, what is the skill or knowledge that you use quite often? And also, does whatever that you have learned in your undergrad years helped as well? Okay, so maybe Jackie, you want to go first? Yeah.
So the most useful skill is programming.
Okay.
Okay. And yes, my undergraduate was in information technology.
Okay.
So whatever I learned is still useful there. And I spent a bit extra time playing a lot with Linux. So that has helped a lot.
What's your first programming language then?
I started with C, then Java, then I learned Python on my own. After that, I worked in assembly for a while, working on routers and stuff. Then came back to Java. So after that, it's mostly Java, SQL, or Python. Okay. Sometimes we use Scala if it's Spark related.
Okay, before we move to the other panelists, right? Because let's go with that. Because I do get a lot of people asking me the question, hey, if I actually have some programming background, let's say in Java or whatever, is it easier for me to move to other languages? What's your thoughts on that?
So if you know Java, you can very easily work with C#, and maybe even JavaScript. So all these languages which do memory management for you. going to C or C++ may be a bit challenging because you need to manage the memory on your own. But the complete, like a paradigm shift comes when you go to functional languages. So you need to retrain yourself. SQL also, I would say SQL is quite different compared to Java.
Hello? Yeah, I say you can't escape from programming. So to be a data scientist or to work with data, you need to be able to program to use the data. So maybe I won't talk on that as much. I think Jadip mentioned that a lot. I think one thing we do a lot is logic and reasoning. For example, let's say someone comes to you with a problem like, okay, can we try to increase conversion or increase sales on the website? What do you mean by increase sales? Is it revenue per card, or is it lifetime revenue, or is it revenue per day? Which one of these metrics actually drive business output? So that's not something that you often see in an online course. You'll have a lot of technical courses on machine learning and optimizing, but no one actually teaches you how to choose the right metric. Yes, it's RMSE, but at the day level, at the card level, at the lifetime level, session level, whatever. So I think logic and reasoning plays a part, as well as statistics. So that's what I feel.
Michael?
Yeah. So managing dashboards, you basically need a very, very good understanding of SQL or SQL, because you're getting, if in most cases someone else is feeding you that data, and you basically need to understand really carefully what the data is, where it comes from, and manage your queries, because you're basically pulling those in. And a lot of times you have to troubleshoot. And my experience with most BI or software across different companies is that they always would say that their query language is somewhat near SQL. So if you learn SQL, you could slowly pick up a few other ones. Like ClickSense, the query language is roughly similar, for example. So that one is a foundation. You make sure you can pull the data whenever you need it. The other part is that sometimes you get ad hoc requests that are unexpected. So a little bit of automation, scripting, or macros helps a long way. So for example, someone recently asked us something, hey, I need this data. And luckily with a macro, we ran it overnight for 36 hours and we got the data. But if you did it by hand, good luck, right? So that's the basic fundamental skills. You need to be very good at managing the data and getting the data efficiently, right? So that's the first step. The other step is that as visualizations is very key, right? It's basically a little bit of design, and communication. So luckily what I did back in my business degree is I majored in marketing and also did operations. So that helps. That really helps because it tells you like how should you communicate a certain message. The most key part is that you need to understand what the challenges the business is facing. So if they say gross profit, you better not go, what's gross profit? That's not the right answer, right? So you need basic business fundamentals to start answering the questions that come, because you're basically the consultant. You're the guy who is sitting on treasure trove of data, right? So you basically have to answer those questions quite carefully. So that's the other side of the thing we're looking at.
Usually you forgot to share what's your background, your undergrad.
Yeah. So I don't come from a technical background. My background is actually in psychology. That hammered in stats and human behavior into me. So I find that that's actually fairly useful now. Nonetheless, the programming part I picked up on my own. So fairly decent at it, I guess. Good enough to be employed. Yeah.
Same.
So my bachelor background is chemistry. So by that time I had to do some hands-on chemistry experiments in the lab. Later on I moved to the computational chemistry, so at that time I completely carried on some other languages. So by the time of my bachelor, even I'm a chemist, I still learn C, so for a few years.
Okay.
Yeah, so it's like quite coding intensive later on for my job. What I learned from my bachelor.
So what skills from your bachelor helps in your current role?
Yeah, just the coding skill and some of the way that you have to think, the research mindset. I think that's useful. And currently my day-to-day work, I have to use Python. For Python library, you can call the most useful library I found is Panelists for data manipulation. Matplotlib for visualization to show the stakeholders what you've done. Some other things are just the basic understanding of the machine learning. All the machine learning models are also useful because that's just your day-to-day work. You use them all the time.
So to summarize is logic, business thinking, statistics, and I think the common theme over here is programming. Right? All of you have been mentioning that you program a lot. So I'm going to ask for the rest of you who may have that question, and that is, how do you all learn your programming? And was it tough learning the programming? And is there any learning tips that you have picked up to learn programming that you can share with the audience? So let's start with Michael.
Yeah, so coming from a business degree, I definitely didn't learn any programming. A little bit is, okay, you might not count this as programming, but I basically dabble a little bit with Excel VBA, so that helps a little bit. You create a little bit of macros to save some time. That helps a little bit, but a lot of it is self-trained. For example, one of my jobs, back then I actually didn't know SQL when I graduated. So one of the internships I got is like, we need you to learn SQL. Okay, I learned SQL in 2 weeks. There's online trainings with it, and once you are capable to do the queries, you know how it works, that's enough for you to branch off. And then from that point onwards, I started picking up R or Python, both ways, simultaneously. So you get to at least know how to handle the files, how to do certain basic actions. So from that point on, it's pretty straightforward.
Okay, so I think learning the coding is easy, even you don't have a computer science background. There are some like Python in 3 months, Python from scratch, or Python for total beginners. Those kind of courses, just follow some of them and check the review score. If the score is high, I think it's effective. You just learn and follow the steps. First, print hello world and just do some data structures. And I mean, it's easy because you don't need to learn, for my role, you don't need to learn all the functions or all the things you can do with Python. You just need to learn all the related things with the machine learning models. So don't spend too much time on learning those. It's a tool, so I hope everyone can find it easy and just, I mean, if there's only one machine learning one coding language for me to recommend is a Python for my role.
So as I mentioned, I started with C, which is like a brutal choice for a first language. So it's very unforgiving, right? So as soon as you start writing anything fancy you want to do, you run into a segmentation fault. So I think it was the first course in my college, and we had like 50 assignments in C. So almost like 2 or 3 assignments per week. And
wow, okay.
I think by the 10th or 15th assignment, I got the hang of it.
Okay.
But the good thing is, once you see after that, other languages are quite easy to do.
Okay. So the conclusion from you will be lots of practice.
Yes.
Right. Force yourself to actually have like 3 assignments a week. So 3, the magical number is 3 assignments per week, okay, programming. Okay, yeah, think about that. Okay, Eddie?
There is, I don't know, the creator of jQuery, John Lessig, he has a saying which says, you must write code every single day. Push something to GitHub every single day. And he still does that, I think.
Yeah, so 3 assignments, push codes to GitHub every day. Every day, right? Every day, yeah. Every day, I think it's better, at least it's not every hour. Okay, good. Eugene?
Cool will be watching your GitHub repo just So I think my first language was R. I did psychology. We ran a lot of experiments, mostly statistical programming language is R. Who here started with R? Wow, okay, not that many. I guess it's not so popular now. Then I did some machine learning competitions. I ran into some problems with R. So I moved on to Python. Then in one of my roles, we had to use Spark, and we decided that we'll use Scala Spark because the Python API wasn't so developed then, so we used Scala. I think I was fortunate to be able to apply this on my work every single day. So I think the key thing that Jali mentioned was after the 15th assignment, you get over it. So I think there's really no getting away other than just practice until you just drill it into your head. Some people are more talented than others, some people learn faster than others, but I think everyone here probably has a good enough learning rate. What's left remaining is just the discipline and the effort you put in to really get through it. I think it's not difficult at all, just like what Reina said.
Okay.
So maybe I'll add something.
Sure, go.
Google and Stack Overflow is your best friend. A lot of people think that, oh, I need to learn exactly the entire package and the entire Python, but a lot of times I think you overestimate how common your problem is. Like usually most of your problems, someone has that problem before. So as long as you get the basic foundations up, right? You get on the way, you can learn a lot more from looking online every day.
Okay. So Stack Overflow and Google, yeah. That's okay. So anyway, okay. so now you know why we hold the panel over at Google over here. Yeah. Okay. I think it's time for us to open to the floor. Any questions from the floor? Okay, I have to tilt my head, right? Okay, sure. Okay, actually I'm monitoring this. So let's continue then. I think all professions will have boring days and exciting days. So can you all describe what's the most boring part of your work and what's the most exciting part of your work? I just want to warn you all, it's recorded. Yeah. Okay, so maybe Reina, you want to start first?
Maybe I start from the what is the most boring day? Because I don't have the computer science background, so for computer hardware things, I'm not good at. For example, recently I have to install something named Apex. Apex for parallel running on some of my package. So that really is my biggest headache and troublemaker. I've been struggling with this for one day, then I didn't get any clue. So I think I'm short of those knowledge. So when I can't get really the model to run, and I know that myself have to catch up a lot of those background knowledge about computer science, I feel a bit bored. So boring is not about you have nothing to do, it's about you know you have to do something, but you have to achieve something really challenging, but you have no way to go there quickly. You have to settle down to learn slowly. And the most exciting thing is just when you have some good result, and when you read some news report about the new machine learning model that can achieve so much more, and you just think about the future, you feel so good about mankind.
Wow.
Thanks.
So good about mankind, yes.
yes. I mean, just like the feeling about the future.
Okay. Wait, Michael?
Yeah, so most boring, I guess, is because I guess most companies have a huge array of data sources, and once in a while you come to those days that is there any way we can extract this better? No. Okay, we got to split up the work. You take 1 to 5, I take 6 to 10, you take 11 to 15, and then we split up the task and just get our heads into it. So there is times that you have to get down to dig the data out, or you basically saying that, okay, we need this deck, it's huge, but we have to make sure that the whole deck is really correct, because not a single number can be wrong out there. So you put down some music, and then you make sure you're focused, and you bury your way through it. But the exciting part, I guess, is at the end. So most of the exciting parts is as a business data analyst, is when you work through your problem statement with the problem statement of the stakeholders that you're working with, and then you go through the entire process saying that, okay, this is your problem, this is what the data says, and the exciting part is when they really tell you that, hey, we did this business decision based on your data and your insights, and that really works, and that is what I guess gives the best excitement. right? So it's really exciting to know that your work has been put to use and that it has created a difference somewhere.
Impactful.
Impactful.
Yeah, okay. Jenny?
So I agree with him. Sometimes SQL can get really boring. Like you're just writing a job, selecting like 100 columns from a table. You're just doing column 1 to column 100. Then you run it and then you see, I think you missed column 99, right?
Yeah.
Then you have to go and look through all the lines of code one by one again. So that can get really boring and question is there a better way to do this.
No, there isn't.
Exciting is usually you get to learn, you always get something new to learn, and there's a lot of new stuff which keeps happening. Every few months there is something new, also software or something which gets released. So just keeping track with that and see if that can improve processes, can we use that, so that part is really exciting.
What really drives us is that when something we build or something I build is put into production, and then we get feedback from the user, hey, no, this is actually really useful, and this is how we can improve it further. I mean, it's similar to what Michael said. The fact that something we built is delivering value, improving someone's lives, especially I work in healthcare, that is very exciting for us. So that is the finish line. The finish line is not when the model is designed. The finish line is not when. The finish line is when, okay, they said, let's go to production, and then the second finish line is someone actually use it, give you feedback. That to me is the most exciting part of every project. The most boring part is documentation. So it's something that's absolutely important. I try to do after every 20 days of real work. I spend a day or two summarizing all my thoughts in documentation, updating my doc strings, writing test cases. But it's absolutely important. If not, if you revisit the project 6 months from now, or someone jumps onto your project trying to contribute, they wouldn't know where to start. And that prevents you from scaling. So, but documentation, after writing it for more than 2 days, you start to get tired and you just want to write code that runs.
That runs, yes. Okay. Wait, okay, so that's one thing I noticed was that was, I think the part about learning, where that's the exciting part. Like for instance, like if there's new algorithms that comes out, interesting algorithms that comes out and all this, that's where it keeps all of us very excited. Now, let's talk a bit more about the learning then. Let's talk about how do we, so can you share a bit more how do you all learn, given the fact that the technology that we are working with, right, changes so quickly and always gets updated so fast, right? How do you all learn? How do you all pick up? Do you have any, like, maybe even learning resources that you can recommend as well? Eugene, you want to start first?
I'll address these 2 ways. Two points. So firstly, yes, you need to learn to stay up to date with industry. What's the best way to learn? I think the best way to learn is to learn something that you can apply immediately to work. That way you can see the outcome, you can get feedback immediately, you can iterate faster. No point learning TensorFlow if you're using PyTorch. I mean, okay, so...
sorry, transmission problem.
No point learning C if you're using Python. So that's what I do. I think if you want to be at the edge of this field, you just have to devote the hours to really keeping up with the industry. I mean, the industry is moving so fast. DeepMind is releasing new paper on GAN every other time. NIPS has new papers. Spend some time to read through the papers, understand what other people are doing, etc. So I try to read 2 papers a month. In my team, we do brown bags a month. Every month, everyone shares a paper. So that way we scale the learning, parallelize it, someone shares a summary, etc. So that's how you need to keep up with the pace of technology. But the one thing that actually, then there's also the meta to learning. There are certain things there are certain fundamentals that are transferable across everything you learn. For example, code design. How do you design your code base properly so that other people can easily contribute to it? It's modularized. This applies to almost everything. Code style. How do you replicate research papers? Do you spend a lot of time finding data? What's the fastest way to replicating a research paper? Someone can do it in 4 weeks, someone can do it in 4 years. So that is a skill that is transferable across everything you do. How do you read documentation? How do you explore a code base? For example, Spark 2.4 is out, there seems to be a bug, or you don't know what's going on the surface. How do you explore the Spark code base itself to really understand what's going on behind it? How do you Google? How do you Stack Overflow effectively? I think these are meta skills that apply across everything, and you should always be focused on the meta skills on top of the technical flavor of the month that comes along every time.
Jody?
I would say, I think you should learn what you like and don't take it like a homework activity that you have to do. Oh my God, I have to learn every single thing. That is impossible, right? And there's so much new stuff coming out every day. There's no way you can find so much time to learn that in depth. So I think I would let my interest guide me towards what is the next thing I want to learn. I also like to learn old things, which is like some old command in Linux which can do a job. Usually I would write Python or Java code for that, but there is usually a command which will do this. So learning stuff like this, that also is very interesting.
Okay, to that point, right? Maybe let's touch on that point. So so far based on learning from the older things, right? What do you realize what are some of the maybe the concepts that you can still bring into modern days then?
I think every single thing.
Every single thing.
Yeah.
Okay.
So one way to look at it is like what is small data today was big data at some point.
Okay.
Right. So how do you sort a file which you cannot load into memory? Right. This is a very old problem. So if you try to read algorithms that came up maybe 70s or maybe even older than that, and the same thing is being used in, if you look at Hadoop or Spark or something. So just go deeper.
Dig deeper and then you see some of these things get repeated even in the new technologies.
I don't think something radically new has come up.
Okay.
It's all the same old.
Sure. Any learning resources to recommend for people who maybe want to take up your role?
Hacker News is good. Like
Hacker News.
You get a lot of good programming articles from there.
Okay.
There's a lot of qualities there, but the code articles that do get uploaded are nice. Reddit is also, if you filter the groups of Reddit.
No, Reddit refilters, okay? Reddit refilters, okay.
So I've been using, I've been checking Reddit since 2006.
Okay. So what's the most common subreddit you go to?
I go to programming.
Programming. Okay. Programming. Okay. Yes. Michael.
Yeah. Shout out to the organizer. First place you can learn is join the Facebook group, DSSG Singapore. Obviously, if you look through that, we also did a research GitHub of all the learning resources. That's really good. But on a serious note, as he mentioned and as Eugene mentioned, a lot of your learning is based off what your current problems today are. Like, hey, it's really slow, I want to try something else. Then you look into different YouTubes, go through the different videos, talk to people, find out what's their approach and what's their problem. Because a lot of times there's no one best solution. After you learn something else might have come out and say that, oh, this is a new big thing. It's like, is it really the new big thing? So you really have to take a look into it, right? So that's a lot of the learning part. That is that. I actually agree with you. You have to learn how to Google really effectively, and especially on Stack Overflow. If you have a unique question and you think it's really unique, how are you going to post it up such that it's not going to get banned? No, this is a repeat question. Because I've done it a few times before, so I thought I got a really good question, but no, it's still not phrased well enough. So that's the meta skills of like learning how to search for things, right? I think that you have to pick up over time.
Okay, Rina.
So for my role, it's quite scientific. So I suggest people who want to keep update can check this website. It's called Archive. So there's a lot of scientific papers. You can just navigate to machine learning. Then you can get some updates, or you can just get the new machine learning updates from the news reports. Otherwise, I think most of my updates are from my working environment. For example, my colleagues are quite active in the blogging or in the GitHub repositories, and they will just pass those new information to me before I really get it myself. Also, the head of RIT, so Radcliffe Institute of Technology, he was really active about all of those new information, new models, new technology. He really wants to bring those new things to RIT. So every time we have all hands meeting, he will also report to us.
Okay, I think continuing on the learning part, right? I saw one question that I think I would like to ask also, and that is, I think some of us here have taken a master's, and I know a few of the panelists have already taken a master's, or currently taking masters, or have taken masters as well. So maybe can you share a bit more how the masters have helped in your work? How the masters have helped in your work, or if you have taken a boot camp, how that boot camp has really helped in your work. I think Michael, want to start first?
Sure. Master's program. Yeah, so I did a master's in SMU, this MIT Analytics Masters. So first of all, you need to get into the master's program knowing what you want out of it. You have to have a goal before you go in. It's not a magical upgrade. Right? It's like you don't just go through the course and then you suddenly a much better person. A lot of it is that you can get in touch with the academics, the professors. The way I found that I got the most value out of it is that you basically have to experiment and read up on your own a lot. Then you go to the class and you test it and say that I tried this, is this going to work? And then, I have this new approach. So there are a few times where I actually suggested some stuff that the professor's like, what's this new approach? And actually it works out quite well. And that's where you learn out of the program, I think. It's a lot of it is also the people you get around with, because mine is physical, also got analog masters, you actually meet people. So it's a lot of your classmates, you interact with people from different areas, you get that experience. Because we have guys who have worked in banking in like 20 years, and their experience actually is very valuable. So that's, I think, one big benefit of the master's program is that you get to be in touch with a lot of different people from different areas with varying amount of experience, and of course you get in touch with the academic side as well.
Okay. I know Michael. So I know Michael actually took a dive, as in like he resigned and then took a master's full time. So, and after that, after the master's, he came and looked out for a job and all this. Can you share a bit more experience of like using the masters and then looking out for jobs? What are things to look out for maybe those who are taking a master's now?
Yeah.
Yeah.
So first off, having a master's is just one more question the interviewer will ask you. So what do you do in your master's? What really helps you is that during your master's program or whichever learning program you have, start creating a portfolio of your projects. If you can put them up. Because eventually the current company I got hired at, actually the person said, yeah, the CV looks okay. Then he clicked on the link on the profile, on the portfolio that I had, and said, yeah, this looks really interesting and this looks like what we want to do. So I guess through that, if you take a deep dive and say, I want to take a master so that I jump from one role to another role, because before this, I was in market research, so quite a big difference actually. So it really helps a lot if you get a portfolio up. Make sure you run through enough projects that exposes you to different things, not just what you're comfortable with. So in fact, I actually took some banking modules that has nothing to do with it, but I realized that, this actually helps a lot. In fact, when I first started my master's program, I was like thinking, yeah, procurement, not going to be very fanciful, right? What was it related to? Then the job now I have, is related to procurement. You never know what you might need in the future. I think it's good to keep a wide breadth on a master's program.
Ready?
So I did a master's in computer science. If you are just working as a programmer or engineer, I don't really think there's a lot of difference between programmer who has done undergraduate versus a programmer who has done masters. But the main thing I learned was I did like master's per research, so you have to write papers and stuff. So the thing which I learned was like when you do write papers, you have to spend a lot of time figuring out has this been done before and which all labs or what approach did they use. You have to cite the lab. That skill has been very useful to me.
Michael, you think that? Yeah.
Now he reminded me that that's the same opportunity I had to read up Chinese academic papers.
Chinese academic papers. Wow. Okay.
To polish up Mandarin. So I agree with him. It's a good chance to look through all the academic stuff.
Okay. So Jadip, you took your masters full time or
Full time.
full time? So how was it like to then after that go back to the industry again?
Yeah, so it's a big story.
Big story. Okay.
So
Let's take the popcorn first and yeah.
I did masters by research. I almost went into PhD.
Okay.
I even applied to a few PhD programs. I luckily got a job in Singapore in a startup. So I thought maybe I should earn some money now and think about PhD later, and that's how But as soon as I was back in industry, I really liked the job. So after that I didn't look back.
Okay. Eugene?
Okay, so my background is in psychology. So as I was working with using data, machine learning, etc., I felt that there was a sort of a ceiling. I was lacking some of the fundamentals in computer science, so therefore I decided to take a master's in computer science. I think what Michael and Jadip mentioned, the component about writing in masters, or at least I had to replicate some of the, for example, the DeepMind experiments on reinforcement learning, or had to build some very core fundamental algorithms from scratch, like alpha beta pruning or whatever. I think that gives you a lot of practice, a lot of rigor, and sometimes you might actually, almost all the time, I had to write up about my report, my findings. The ability to, it really hones your ability to write as well. So I think in the masters, you get very structured practice, get very structured feedback on terms of your programming and your writing. I think the other thing is also you learn things and you can apply it immediately at work, hopefully. Almost everything you learn, you can almost find a way to apply it. So I think it's useful.
Okay, so actually Eugene took a part-time master. So for Eugene, since you're working and taking masters at the same time, right? What is the key essential ingredients, right, to help you get by day to day? Since you've got to manage both.
I think the key ingredient is that I basically don't have a social life. No, but okay, I mean, some of these modules are really tough. I think a couple of people take this part-time masters with me as well. It's like 30, 40 hours a week. So my weekends are just at home. My weekdays and weeknights, if I manage to get home from my startup job, I was in a startup, I'm now in a startup. If I can afford some time, I'll squeeze in a lecture or two or write some code before I collapse. But it's not easy. If I had known this would be like this, maybe at that point in time, I would seriously have second thoughts. It's quite difficult, yeah. And your travel schedule is basically around, hey, my exams ended, let's travel. If not, you probably can't travel much. Yeah. But not to scare anyone off doing a full-time master's. A master's is very rewarding. Yeah.
Do you want to share which masters you're taking?
It's this college in US. I don't know if you heard of it, Georgia Tech. It's not bad computer science college. The profs are really good. The education is really good as well.
Okay. Okay. I'll touch on the next question that a lot of people ask, and that is, okay, is PhD essential for your job role or not? If so, I'll let Reina start first.
So I didn't get to talk about the master because I already have a PhD. So my PhD is in computational chemistry. I think it's quite necessary because for my current role, because the basic knowledge has been covered mostly in my PhD study. That time I had learned like the area and the curve to analyze things and to learn what is a gradient descent, all of those optimization methods. But if you want to take a PhD, first of all you have to check. For example, there's IBM forecast, and you see that 5 years later, what does the job market look like? Maybe by the time you graduate, the job market has changed. Now I think it's the demand is much greater than the supply for data scientists. And for recent years, still should keep this trend. But I don't know, 5 years later, just keep yourself updated with those forecasts and not miss a good chance. Master is suggested, I think, at least to do the computer science. And during the master, you can still like do some internship. And when you do some internship in that company, then they tend to want to recruit you if you have some decent results. So that's a good chance. But PhD, I don't know, unless you really want to take up some role, like really scientific. My role is already scientific enough. If you want to take up my role and you come to the interview, and if I were the interviewer, if you have bachelor or master, I think that's still okay. If you have some basic numerical statistics, some basic linear algebra, and some Python coding knowledge, coding ability, familiar with the command line interface. Those are something that are basic you have to know, and I think you have to have some projects that demonstrate you can really do something to impact the company. Then that's enough. The degree is not so essential.
Actually, I take a very different view on this. I am of the view that you don't even need a college degree to get a job. I think recently you've heard the news, Google, Apple, IBM, Bank of America, they don't even require their job applicants to have a college degree. And I recall seeing a list once of like the top contributors to TensorFlow or the top minds in data science as we call it now. Most of them don't even have college degrees. The best people I've hired, self-taught, like from electrical engineering or from chemistry or from operations research, they all self-taught. So I definitely don't think you need a master's, don't think you need a PhD. I think even without a proper college technical degree, you can actually learn everything yourself thanks to the internet. Yeah, so that's my take.
Jenny?
So I would say PhD definitely not a requirement for a data engineer role. But I am not really sure if you need a college degree or not. So I can't imagine a scenario where you don't need that education. As a programmer, if you don't know operating systems or databases, so I think it's quite essential.
Sure. Michael?
I don't think you need a PhD to be a business analyst. You have a PhD creating visual charts. But then I think there are some people who do that. So I guess back to Eugene's questions. So as you work with, as a data analyst, your main customer is always your stakeholders, whether it's operations or marketing or sales or C-level management. The business degree helps to get you the language that they're talking about. That helps. The master's helps you to refine your skills further, put it into good use. PhD is not really that required in the business data analyst role.
Okay, so we move on to another aspect, and that is actually not really another aspect. It's more of the tools. I think some of you are interested in what kind of tools that you all are currently using now. Let's say, what is the go-to tool, at least for the beginners who wants to work in the data science field? What's a go-to tool that you would recommend them to pick up first? Okay, so Michael, why don't you start first?
Pick up Excel first. Though seriously, I've seen some part-timers come in and say, could you do Control C, Control V? And then we asked her to draw a chart. She started drawing rectangles of different lengths. so I don't think anyone in this room is at that level so that you go that far down. Excel gets you started straight out already. Of course, you need to start picking up SQL and all the other stuff. That's the step-by-step approach, I guess. There isn't really a formula for this.
Weina?
For me, just learn Python. As I already told you before, Python library is a Panelists, NumPy, Matplotlib. So for other things, you have to know include. Because currently machine learning has some trend to move things to deep learning. Deep learning is part of machine learning, but it's just more powerful when your data scale is really large. So since the deep learning comes up so quickly, you have to learn some deep learning tools like PyTorch, TensorFlow. Yeah, they are equally.
Is this like a VI and Emacs thing? TensorFlow and PyTorch. That's what I don't really use.
They are just a platform that you can call something, and they're just like the entire ecosystem you can run TensorFlow.
Is it something like you will fight each other to death if one guy uses TensorFlow and the other guy uses PyTorch?
No, it's all just matrix multiplication and the chain rule. It's all the same. It's all the same.
Yeah. So, you want to add more?
Okay, so I would say at the least Python and SQL.
Okay.
SQL is most data engineering jobs are moving towards completely SQL based.
I would agree with most of the panelists here. It's SQL to extract the data, because you don't want to be the helpless data scientist waiting for someone to give you the data in a CSV. And Python to manipulate the data, like what Weima mentioned, Pandas, Matplotlib to explore it. I don't know, you want to run some machine learning algorithms or not. sklearn has pretty clean and easy to use API. TensorFlow, PyTorch, XGBoost, LGPM, Hyperhop. There's a lot of stuff out there. Just pick what you need. You don't need to learn the whole ecosystem overnight.
Yeah.
And one thing, because I work quite a few different companies, is that as data analyst or BI, right, there's every time you change the different company, they might be using a different tool set altogether, and you have to learn that one straight. So if someone said Spotfire, Tableau, Power BI, ClickSense, just learn one of them, whichever one your job currently requires. So that's the one you need. But I guess there's also, what I'm trying to learn now is like, what are the free options available? So that's Superset. You can basically create charts on go and upload it, and you don't need to pay a single cent for that. So that helps.
Okay. So two sides is Python, SQL, Excel for data analysts. Nothing wrong with Excel though. Just okay. So we'll take one question from here. Yeah. Any questions from the audience? No. Yes. Yeah. Thanks. Hey, I think it's supposed to be your job, eh?
So I'm wondering about the value of this competition platform, such as Kaggle. So do you guys participate in those kind of competitions to help you improve your skill?
Okay, so do you all take part in Kaggle, and if you do, right, what did you gain from it? Can I summarize it as that?
Mostly a data science question.
So yeah, I think why don't you go first? Yeah.
He just said it doesn't apply to him.
Oh, okay. Sorry, my bad. I was like so focused on Eugene. Okay.
Because I think it's suitable for my case because I'm a data scientist and Sometimes people ask me whether if I don't have a PhD, can I join your role? The answer is yes. So you just have to learn all the basics I just mentioned and join some Kaggle competition, because Kaggle competitions are quite valid projects. Those are real, those data sets are cleaned by those companies, and they do have some problem they want users to solve. And they provide user data. That's a very good chance, and you can connect the dots that everything you have learned. Maybe you didn't learn everything, but you just connect everything you have learned and apply to that project. Maybe after 1 or 2 projects, you have a sense of what is a data science project look like, whether you really like to pursue this career, or after 1 or 2 projects that you have something to demonstrate to the interviewer what you can do, even you without a PhD. So that's a quite nice platform.
Okay, Michael.
Yeah, so Kaggle helps whereas if you are like a fresh grad and you didn't have work experience, and if in the interview asks you, do you have any experience? No. So Kaggle helps you with the data set because they really give you a problem, you're just trying to solve the problem. So a lot of times I think it's how you walk through that problem, how you look into it. The other one for us, as in visuals folks, there's also the other challenge is fast. Annually they challenge you on visualizing data. Google that out. That really helps you because they give you data sets really, and you're trying to go through that aim. So it helps. I've tried a few, and I don't think I got great results, but I think I got great learning experience. First of all, you attempt it, and then you realize the leader has a far superior method, and then you realize why. So I think that's a very great experience.
Okay, so continuing with that, so how would they Google? Wait, how do you spell the word vast or?
Okay, let him Google for it first.
Yeah, I don't have my phone with me. I think it's VAST.
VAST.
Yeah.
So just look for VAST on Google, you should be able to get it.
Should be. Yeah.
You don't get the dictionary, right? You should not be getting a dictionary, yeah. Okay. Anyway, yeah. Eugene.
I think this is a great question. Firstly, I think a lot of the panelists have shared about how Kaggle is amazing. Yes, Kaggle, you get very beautiful, clean data sets. You get to practice your machine learning skills, your ninja hacking skills immediately. And the one thing about Kaggle is that you get immediate feedback. That is important for your learning iteration cycle. You get immediate feedback, and you get to compare yourself against your peers or against people who are taking part in the competition. That itself is very useful feedback. Like, hey, how well do I do? If after 3 or 4 competitions you're still in the bottom 20%, maybe you probably won't enjoy this that much. So Kaggle is that one thing. Interesting story, I actually know of a person who got hired based on Kaggle. So there was this someone who did a product categorization challenge on Kaggle. So he did a sharing at a meetup, just like this. He did a sharing at a data science SG meetup. So one of the heads of data science or one of the people at an e-commerce company happened to see the presentation, and then they invited him in for lunch. And, we have a product categorization problem, and we saw that. And this person, he took part in the competition. He took the effort to share the competition as well. So whenever you Kaggle, do spend an hour or 2, write up your approach, blog it, share it, make it publicly available so people can know how you actually perform the challenge. They want to know your thought process. And then so they invited him in, they said, we saw your slides, can you present to us? So the guy presented his slides, he presented his thought process, methodology, and the next day they sent him an offer. So you can actually get a job through Kaggle, though I think this guy was probably pretty damn lucky. Yeah, honestly. But then let me add the flip side of things. Who here actively practices data science in your day-to-day job? Okay. For how many of you, and Rina as well, for how many of you is machine learning more than 50% of your job? Anyone here? Machine learning is more than 50%? You have a great job. We need to talk. I'm joking. For how many here, machine learning is more than 30% of your job? That's cool. But so what you see, right, is that machine learning is a